This session is about how the Gradle team dog foods the automation, how we do automation, what are the key patterns that we use, and there's just so much stuff we automate, and I'm not going to go deep into those subjects, and I don't think I'm going to cover everything, but I will promise you that I'll cover the most important things. So let's get started. I'm Szczepan Faber. I'm a core developer at Gradle. You might know me from Mockito framework. It's a pretty awesome framework, mocking framework for Java. All right, so Gradle project is a really distributed project. Like every developer, every core engineer is in a different time zone, potentially even on a different continent. So you can imagine what challenges we have. We solve those challenges partially due to excellent automation. We do releases around every 6 weeks. We feel that, well, I call it frequent, but I guess it's relative. We feel that 6 weeks is just right about. The code base is about 17K lines of code. We have several thousand tests, 2,000 test classes, including the integration tests. We have a lot of them. From the standpoint of Gradle multi-project build, Gradle itself consists of about 40 modules. Documentation, so the user guide, DSL reference, all that stuff is a part of the Gradle project. So if you clone the repository, it's going to be there. Also, the release notes are a part of the project too, which is pretty cool. We didn't have that in past. I remember before Gradle 1.0, the release notes were maintained on the wiki, which was not so convenient. Now the release notes are a part of the project, which means we develop them simultaneously with writing features. Later on, I'm going to show you that we already have a bunch of release notes for Gradle 1.4 with pretty meaty features waiting for you. Okay, so we believe that automation is critical for high-performing teams. This is our mean to achieve high quality. For us, it's a continuous investment because it's not only refactoring and improving the existing automation, but also new problems arrive, right? New use cases, new situations with clients and with our users that require us to update the way we work and potentially provide more automation. It's also everyone's responsibility, meaning that everyone contributes to it. We don't have one person who does all the automation stuff and we just write code, yeah? Well, on the other hand, I can say that Luke Daly is doing a lot of automation recently. Well, let's keep on doing that. All right. So developing and automating the day-to-day at our team. I'll start with something fairly simple. This is the IDE support. We are firm believers in an automated import process so that you clone the sources, all right? And you should be able to automatically import that to your IDE and everything should just work, right? You can run tests from your IDE. You can write code that is nicely compiles. So we hate those long wiki pages. You might encounter that in past when you work for like some teams that, before you even start developing, when you join a team, you had to spend 2 days on setting up the dev environment, going through the 20-page wiki that describes all the steps. So no, thank you. We want the import to be smooth. So what we do, I'm going to show an example based on IntelliJ, and we're going to move on to the more interesting stuff soon. So in Gradle, when you have the repository cloned, you can just do, I'm not sure why my laptop is so slow, but let's continue. We'll see how it goes. Well, I can just run the IDEA plugin, and it'll generate the metadata for IntelliJ. Then I can import that to IntelliJ. Another interesting, we facilitate the Gradle wrapper to make the import easy, because you don't have to have Gradle installed in order to work with Gradle. You need only Java, you need only IDE, and thanks to the wrapper, you can run the task to generate the metadata for the IDE, and Gradle will be also downloaded for you. If you haven't heard about the wrapper, take a look at our documentation, we have a dedicated screencast to the wrapper on our webinar pages. We like consistent setup, so and basically automating the import process is something that augments your consistency, right? If something is automated, it's pretty much consistent across the dev environments, and consistency is a good thing. Less problems like, hey, it doesn't build on my machine, but it builds on his machine, right? So yeah. Another interesting thing is that when you import a Gradle project to IntelliJ, the tasks that you often run from the command line, you can also run them from the IDE because we automatically create those run configurations. And this is all implemented using Gradle IDE plugins. Okay, so it's completed. I'm gonna jump quickly to, let me close everything. Yes, I wanna reload. So IntelliJ has asked me whether to reload the project because I regenerated the project. But it's not a big deal. You can also generate the idea metadata in a way. It does not require you to reload the project, so it's all possible. Now I need to close all that code that I've been working on. Okay, that's that one too. How it's implemented. So we do have a build.gradle in the root project, right? And then we encapsulated various other Gradle things and setup of our project in a specific build script. They live under the Gradle folder. In the Gradle methodology, those are called script plugins. So let's take a look at idea script plugin. This is all the build logic related to IntelliJ. We encapsulated that within that single file. It's doing things like for all projects, it applies the idea plugin. Then it uses a little bit of the DSL to configure certain things of IntelliJ, and then it's doing some more advanced stuff that I'll show in a sec. So without jumping too deeply, there's a chance that in your project you just only apply the idea and everything works, because Gradle is pretty good in selecting the defaults. However, our project is not quite trivial. We automate a lot of stuff, and therefore certain defaults don't work for us and we have to configure them. Therefore, you can see that in this IntelliJ configuration, IntelliJ script plugin, we actually configure some things, some aspects of IntelliJ integration. We have similar file for Eclipse as well. From the interesting things what we do here is that the Gradle IntelliJ plugin allows you to manipulate the generated metadata on a very low level. So you have high-level DSL to configure things, but for very advanced stuff, you also can hook into the XML that is a part of the metadata and basically change this XML. This gives you total robustness and flexibility in setting up your IntelliJ environment, because if some feature is not covered by our DSL and Task API, surely you can hook into the XML generation, manipulate the XML, add any necessary configuration that is needed. I see that I have question from Andrew, so hang on, let me just take a look at that. Is the creation of run configurations part of the plugins, or do you do that special in the Gradle build? Does it support Eclipse as well? Okay, so Andrew, this is the generation of the run configurations, like for example, Gradle run configuration that you see here, is a part of our, let's say, custom build script. So it's not automatically generated when you apply Intel IDEA plugin. So we do it using the with XML hook on the IPR level. And this is also possible for Eclipse. However, I'm not sure at the moment what is the format in which Eclipse stores those. If it stores it as a separate files, then you can have separate tasks that generate those files. So this is possible with Eclipse, definitely, although I don't think we do that for Eclipse. We only do it for IntelliJ. I guess because at the moment most of us develop with IntelliJ. So yeah, hopefully it answers the question. So let's move on. Oh boy, my laptop is really slow. Let's see how it goes. All right, so let's move on to testing, the vital part of any automation. And we are fond of tests. We really like TDD and high coverage. Obviously, we have a lot of unit tests. The interesting pattern I'd like to emphasize is that we do write Groovy tests even for Java code. Certain components of the Gradle platform, especially the core components, the most important ones, are written purely in Java. Okay, so the core sub-project, the core plugins like Java plugin, all written in Java. And that was a design decision that we decided to do it this way. But still, even though the module has a only Java production code, we can still write Groovy tests for it. And this is the pattern that we use. So I'm not sure if this is as interesting to take a look, especially with such slowness. But core project is the core of the platform. It has the source is a pure Java code. So if you go to main Java main, it's gonna have only Java code. And then you have, even though the folder is called Groovy, I'm pretty sure it only has Java code. And then we have tests, which are in Groovy. Thanks to the fact that we use Groovy for testing, we can use the fabulous unit test framework called Spock. It's an excellent. It's awesome. And definitely try it out in your project to have your tests written in Groovy. You will take advantage of much better readability and more essence, less writing. So it's pretty nice. If your team does not know Groovy at all and you are not very keen on learning it, I wouldn't advise to write Groovy tests. I've been in a team where they did use Groovy for tests for their Java code, but their Groovy test looked exactly the same as in Java. It was just like Java code. It's just the class was called Groovy instead of Java. So it does not quite make sense. I mean, you should take advantage of Groovy and get better and better, learn from other team members, and then in that case, it makes perfect sense to have Groovy tests for your Java code. Okay, let's move on. So integration testing, way more interesting and way more exciting at Gradle. So let's actually discuss what is an integration test in Gradle. Okay, I'm gonna attempt to write an integration test. Hopefully the slowness will not hamper me too much. Oh boy, okay. Okay, come on. Okay, let's add the Groovy call. Let's call it demo integ test. There are a bunch of definitions. What is an integration test? At Gradle, we call integration tests that actually evaluate a build script or run some tasks from a build script from some Gradle project. So this is what we call integration test. So I'm gonna extend from some base class that adds some nice features for the integration testing. Abstract integration spec. There you go. Thank you. Wow, it's quite slow. Let's do something drastic. Okay. Let's see how it goes now. Okay, so what I do now is I'm gonna create a build file. Hello, build file. Which will have a task demo. And it'll have a do last action that prints print line hello. Okay, so I have a build file, and now what I'm going to do is, this is a Spock test, so I'm using the labels that are required for writing Spock tests. They're really cool. They make your test look like a BDD test. It's very, very lovely. I'm going to run the demo task, and I'm going to do then output contains this. So I should be able to run it, but it's kind of slow. It's going to be slow, unfortunately. Okay, so this is an example of an integration test in Gradle, what we call integration tests. As you can see, we have some nice base classes. We have some nice machinery that allows us to write those integration tests very easily. So this is also a very good pattern for your, if you have some enterprise application, to invest in your test fixture so that it's that easy and that simple to write integration tests for build the business logic that needs those tests. So, and then let's break it. So if I remove the the bang from the hello, it should fail. This is a test with a very simple build file that I can just inline in my test. We also have capabilities in our infrastructure of the integration test to keep the Gradle project that is a base for the test in the resources. So it's all possible. As you can see, the test was failed, and it should be failed for the right reason, right? Hello does not contain hello all right? So let's make it green to make everyone happy. So as I mentioned earlier, we also have capability to have more advanced project structure if you need for testing, and you can keep that structure in the test resources. I'm not sure if I'm going to have some resources. Unfortunately, I don't have any resources for that particular sub-project, but we tend to use it. And this is another thing, and we take advantage of that fully. If it's so easy to write integration tests, we write a lot of them. It's easy to do a proper test-driven development where you start from a high-level integration test and you nail down the feature, adding more and more implementation and more lower-level unit tests. Okay. So let's get back to the presentation, because I want to explain the different modes the tests can run. The default way of running tests, integration tests, is embedded mode. It's optimized for speed and quick development cycles and easy debugging. It means that the Gradle process that runs a task it basically runs in embedded in the same process where you started it. It means that it means fast. It means speed. It means easy debugging, because I can just plant a breakpoint anywhere in the Gradle code base, and when the build runs, I can step through. However, embedded tests are not good as a, let's say, they don't assure me that much that things are working properly. Because in the real world, when you run a Gradle build, you're actually forking a completely separate process per each invocation of Gradle. So therefore, we have a forking mode of running integration tests, which is slower, because for every build request, the separate full Gradle process is started. But it's more realistic, and we find it very useful because it actually detects problems and bugs. So as the default for the dev environment is embedded, typically our CI builds are running integration tests in forking mode. The way to run integration tests in those modes, I can do something like that. So Gradle W diagnostics. I think this is where I have added my demo test, and I can, for example, do forking integ test. So it's implemented using the task rules, which means what is important is the prefix. So you can replace the prefix with embedded, daemon, or parallel integration tests, and you will run all the integration tests for this particular module in a different mode. So this is all running nicely. It's going to be slow because it's a forking mode, but let's move on to the presentation. The daemon execution mode is an excellent stress test for the daemon. So if you haven't yet heard about the Gradle build daemon, it's a feature that makes Gradle faster and makes the build snappy and really nice and friendly. It's the way it works is that when the Gradle build finishes and you've run this build with the daemon, the Gradle process sticks around for a little bit longer. Therefore, next time when you run the Gradle build, you don't pay up the cost of the JVM startup. You can take advantage of the JVM optimization. So things are faster. And also the long living process gives us, the team, opportunity to add more interesting features to the daemon. And daemon can do more and more stuff in the background, making your build and your environment even faster. So definitely try out the Gradle daemon if you haven't yet. I've covered the daemon in one of my previous webinars more deeply. So why we have a mode for running daemon, all the integration tests against the daemon? Because if you imagine that we have a couple of thousand integration tests, and we have every test can actually request multiple build requests, depending, because some of the integration tests actually run a couple of builds, right? This means that if we build Gradle, it means that the daemon is requested to build something a couple of thousands times, which is an excellent stress test. In reality, if you use the Gradle build daemon for your dev environment and you, let's say, work for 8 hours a day, I doubt that the daemon is requested to build something more than few hundreds times tops, but that tops. Daemon also expires after a certain amount of time, which means that there's a chance that you would use a different daemon through the day. So there you go. We have different modes that allows us to add another dimension to the testing. Also, not sure if you heard that Gradle has a incubating feature of running things in parallel. So Gradle is trying to make some smart decision what can be done in parallel, and therefore potentially make things faster. So this is an experimental feature, but you can still use it. It's available in Gradle. It's still running. So you can find out -- parallel. You can run with parallel. Please read about the daemon and parallel in our documentation. We have plenty of information about how it works. But this is, again, if we run entire suite of integration tests in the parallel mode, it's an excellent stress test and coverage for the parallel feature. We detect all the problems, like all the thread safety stuff that is needed. So this is really useful. And then those different modes are the reason we can pretty easily implement those different modes is that Gradle is a very flexible tool. So if I go to the Gradle subdirectory, which contains the build script plugin, and let's take a look at the integ Gradle file, which contains a bunch of aspects of the integration test configuration. But I'm going to just navigate to the bottom. Okay, it's really slow. All right, so this is where we configure those various kinds of tests. So as you can see, embedded forking daemon, for each of those, we add a rule for a task. So if you haven't yet heard about the task rules, this is a Gradle feature that we facilitate to make it easy to run the tests in a fixed execution mode. If you have any questions, feel free to ask. Okay, so I'm going to stop this now. Oh, it's finished. Okay, so it's forking integ test, and I can also run it with the daemon. All right, and I'm not going to demo it, but this will run all the integration tests from the diagnostics module against the daemon. And cross-version integration tests for backwards compatibility. So I guess we have three kinds of those. One kind is running a test against a set of versions of a third-party tool. For example, a Groovy version or a Scala version. Actually, Scala is a good example. If I go to Scala and cross version, whoops. I'm typing badly. I'm sorry. Integ. Oh, I can't find it now. Oh boy. Hang on. Let's go directly to Scala. I'll find you. I'll find you, my dear test that I want to show you. Source. As you can see, also our integration tests live in the separate source directory. It's implemented using the concept of Gradle source sets. Yes, the compile, I think that's the interesting one. Yeah, that should do. Oh, there you go. So this is so the complexities around the versions is hidden in the base classes, but you can see that we have a target versions annotation that selects for this test actually runs against those two Scala versions. So this is one of the examples, and we have a lot of stuff like that because, as you can imagine, Gradle integrates with a lot of third-party tools, right? We have JUnit, Groovy, Scala, Sonar, PMD, all those third-party tools that we provide via plugins, we integrate with them, and it's useful for us to write tests against various versions to make sure we are compatible. I have a question, so hang on a second. Okay, so one person is asking whether this session will be available. So yes, as every webinar, we put it on the gradleword.com pages, so you can watch it for free from the web. It's going to be available after a couple of days. Okay, so let's move on back to the presentation. So we also have features sometimes that we want to validate against a set of Gradle versions. So this is exactly the same scenario, but this time we run tests against a set of Gradle versions. Hello, IntelliJ, can I go back there? Yeah, thank you. Version. Where are you? Okay, let's go to the first one, cache reuse cross-version integration tests. So for example, this test, it's testing the cache reusability between various Gradle versions. And the starting version we want to run this test against is Milestone 6 Plus. So let me just run it to show you. The interesting aspects of our cross-version tests is that when you run those tests on your local environment, they are run only against the recently released version. So even though I configure that the target versions are all versions from Milestone 6, you're going to see that in IntelliJ, only the tests are run against the Gradle 1.3. And there is a reason for that. We optimize for the quick dev cycles. We believe that most of the bugs most of the regressions we can introduce are regressions against the most recently released version. However, for certain functionalities, there is a chance of introducing regression against a older version. Therefore, when our CI builds are running this cross version test, they will actually run this test against all the versions starting from Milestone 6 Plus. So yes, it's pretty heavy. That's why sorry, I got confused because there's another question. So this is how we optimize. CI is fast machine. It can run every test. Our local dev environment should be optimized for fast feedback, and therefore this works in that particular way. Okay, let's get back to presentation. And let me just quickly see if there are any questions. No. Okay, cool. Yes, so this is this full suite versus recent version only capability, and all our cross-version tests have that feature. Another interesting aspect of our automation is the tooling API. Okay, so tooling API is an official way to embed Gradle, and feel free to jump to our user guide to have a look how tooling API works. But tooling API has something unusual, a very interesting feature. We aim to keep it backward and forward compatible. All right, and we also have tests that prove that the tooling API is truly backward and forward compatible. Okay, in the tooling API, there's a concept of a consumer and a provider. So if you're embedding Gradle in your project, you are embedding your, let's say you have a small Java application, you're embedding it with a consumer jar, and when you request using the API of the consumer, you request, for example, to build a project using Gradle, the consumer will then call out to the provider, will get the correct provider, and will use the correct provider. And the way backward and forward compatibility works in the tooling API is, let's imagine that you bundle your application with the consumer that was released with Gradle 1.0. Okay, so by contract of the tooling API, we guarantee you that this consumer 1.0 that you embed your application with will work with any future version of the provider. For example, you can run the build against the provider 1.6, right? And it will all run fine. Okay, and similarly, if you have a consumer that was released, let's say, with version 1.4 of Gradle, you can still run builds against the provider of Gradle 1.0. So this is, don't worry if this is not so easy, but I guess that's not quite important how tooling API works. I want to show you how we write tests for it. So let's actually go to the tooling API project. Where are you, tooling API? There you go. And here I'm going to jump to the integration tests. Here I have a bunch of tests. We found it useful to name the packages from the time where the feature was worked on. They don't have any effect, they're just purely informative. Let's take a look at one of the features introduced in RC1. For example, maybe this one, maybe more interesting. Okay, so there you go. So this is what we define. We have annotations that we can specify that the minimum tooling API version is 1.2 RC1. The minimum target version is 1.2 RC1 too. So, and then other tests have different configurations of those. Okay, let me show you what happens when I run it. Again, we use this optimization here that when you're running this test locally, we are only gonna execute against the recent version and the current code base. So as you can see, those are the tests that have been run. We're gonna run current consumer talking to the current provider, current consumer talking to the provider 1.3, and consumer 1.3 talking to the current provider. When this test is run on our CIs, it's run against all those baseline versions. So there are way more tests. Okay. So this is another thing we do to make sure that the product is high quality and how we automate our tests. Let's move on. Let me quickly see if there are any questions. I don't see any. Cool. We also test our distribution, which means that we check if the binaries are correct. I'm not sure this is that interesting. Performance tests are quite interesting from the standpoint of automation. There are two interesting things that we have developed. So one of the things is that performance. Let me jump quickly to the performance directory. We do have a way to generate template projects that are interesting projects that we want to run performance test against. So for example, an interesting project is a project with a huge amount of source files. An interesting project is a project with a huge dependency graph with various nesting levels and a lot of dependencies. So those are the interesting projects that we can generate using the build logic that we've implemented. And when we generate, and this is this generation capability is all developed in Gradle. So it's this automation is used, is built with Gradle. When we generate those template projects, we then have performance tests that run the tests a couple of times, do apply some heuristic around the statistical problem errors, and then provide us an answer whether this feature is slower when compared to the Gradle 1.3 or faster. So to show you one of the performance tests that we have, for example, clean build performance test. So this is an example. We use Spock features like unroll and some of the labels. If you are not so familiar with Spock, please take a look. It's a really nice framework. We decide what tasks to run. We decide what is the test project, this template project that we're going to run with. We also have we also specify the maximum regression of memory and maximum regression of time, and we do it because there's always a chance for statistical problem, and we want to keep the performance test fairly green. Therefore, we have to do like 1%, allow 1% regression. So if you look at our CI, and you might sometimes find that some of the performance tests are failing, but it does not mean that the next release is going to be slower or it will need more memory. It just means we are in progress of doing something, and as closer we are to the release, the performance test will be fixed. Also, the full performance suite is pretty slow. It's exclusively hijacks the entire box. So basically, does not allow any other builds to run on the certain machine, which means that it's not so easy to tackle the performance problems and rerun the builds. Therefore, there is a little bit delay between when we detect a performance problem and we fix it. Nevertheless, Gradle releases are faster compared to like 1.0 and require less memory. So with every release, we chip away some of the performance bottlenecks, and the Gradle should perform better. Okay, so let's get back to the presentation. That was about testing. And I think, so this is my favorite topic. It's about testable documentation. It's, one of the nirvana of automation, I guess. Imagine that your documentation is self-tested, is testable, automatically testable. Pretty nice, hey? So samples in the user guide, right? So if you look at our user guide, there are a lot of code samples there. I'm gonna find something. All right. So this is just one examples of a couple of samples. This particular sample, okay, is just a little bit of the build script. The next one actually is more interesting because it's a build script. It's the we also provide the output of a specific Gradle run with a specific task. So it's not only how the build script looks, but also it shows what tasks to run and also shows the output. And this is all tested. Let me show you how. So let's find this. Sample in our documentation. Okay. So where is the docs? There you go. I'm just string searching in the docs. User guide is all in the docs, as I mentioned earlier. Okay, so I found the place in the user guide where we refer to that sample. Our user guide input is in XML, but then during the build process, the HTML and the PDF is generated out of that. So this is how we declare sample in the user guide. Okay, so we have a sample tag for that. There's an ID, there's a directory where to look for this sample. There is a source file that we want to include in the user guide. There is also the output we want to show, and the arguments we're going to use. And the way it is tested is that during the build time, there is a build logic that extracts the samples from the XMLs and make them available for our integration tests so that we can write integration tests with our samples. And we have automated integration tests, a test for all the samples in the user guide. So let's actually take a look. So let's take a look at this user guide tutorial upper directory, which contains this sample. So in the directory, we have a samples directory, there's a user guide, there's a tutorial, and there's an upper directory. It contains one build file. So this is this build script that is included in the user guide. And then this output is compared with the output that lives under the user guide output in the file that follows the same naming convention as the directory for the sample. So we're looking for the upper output. So this is the output. And this is the output that is included in the user guide. And then during the, when we run tests, there's an automated test that validates that. To show you this automated test, I'm going to jump quickly into the, I never remember how it's called, but it's something with samples and something with runner. Okay, cool. So this is the runner that makes it available. It's a JUnit runner, but this is that particular test. It's user guide samples integration test. I'm going to try running it, but I don't remember if the prerequisite Gradle task has run. Okay, so this is failing because in order to run this particular test from IntelliJ, we need to run a specific task from the command line. But I'm going to skip that. You have to trust me. But anyhow, when this task is run, the user guide, this test can run, and it basically validates every sample. For the samples that do not have output, like for example this one, they are just evaluated. So if you have a typo there that would break the Gradle evaluation of this build script, it's going to be detected. Okay, I might have a question, so let me, all right. Okay, so the question from Andrew, are there plans to make the documentation generation testing available for plugin developers? Definitely, yes. We do want to have probably some kind of a plugin for developing plugins that allows you to not only generate documentation with all the features that we have with testable documentation stuff, but also with things like to enable to allow you ease integration tests of your plugin. So yes, we plan that. It's not on the immediate roadmap, so I wouldn't expect anything for that in the next 1 or 2 releases. But this is, we do appreciate that you're asking this question. We have requests for that from our users, and we definitely looking to do it at some point, or waiting for a pull request maybe from you, Andrew. So we'll see. Okay, so yes, let's get back. So I showed you an example how we automatically test the samples that live in the user guide. We also have samples that live in the Gradle distribution. If you don't know about them, how can you learn Gradle if you don't know about the samples that we ship Gradle with? If you download the Gradle distribution, the all variant of the Gradle distribution, it contains the samples. I'm going to quickly, I think I have, yeah. So this is, I'm just in the folder of Gradle 1.0 distribution, but this didn't really matter because what Gradle version I'm choosing, because samples is something we've been shipping Gradle with since I remember. So if you look at the samples, there are a lot of samples that we already have. Each of the sample has some subfolders inside with a further, so this is hierarchical. There are even more samples if you recurse into the directories. It's very cool to learn from those samples because you can play with those little builds. You can hack them, you can run them and see what happens. So definitely, if you're learning Gradle, if you want to find out some stuff and learn more, do use the samples. Okay, I see that Chrome has downloaded the Gradle 1.3 distribution. As you can see, there's a samples directory. We can jump quickly, for example, to Java, and Java has a bunch of samples as well. Okay, so those are the samples. And we also have capabilities in Gradle to build integration tests against the samples. So let me just show you one of them. For example, samples code quality integration test. We created our own JUnit rule that make this rule is responsible for making the sample code quality available for the duration of the build. So when this build runs, you can execute the Gradle tasks inside this sample project. So this is pretty cool. And those we implemented them using the JUnit rules. If you're more interested in how it's done, take a look at Gradle codebase or read more about the rules on the JUnit pages. Rules work very nicely with Spock. This is an example of a JUnit test, but rules also very nicely integrate with Spock. Occasionally, if you browse the Gradle codebase, you will find JUnit tests because Gradle has been for a couple of the development on Gradle started several years ago, where Spock was not around yet. So there are still some JUnit tests there, and we gradually convert them because this one is pretty easy. But typically, some of the JUnit tests are too hard to understand, especially when they used this very peculiar mocking framework, not Mockito, a different one, and they are usually they can't be understood by a human being, and therefore the first thing we do, we first refactor them to Spock. Anything? Anyway, let me go back here. So I showed you an example that in Gradle we've added a fixture code and capabilities to write tests and easily write tests against the samples. Oh, I'm running out of time. I need to speed up a little bit. So build script snippets in the Java docs or the DSL reference are also automatically tested. So really quickly, if you go to the DSL reference, let's go to the copy task, for example. The copy task has some examples here. This example comes directly from the Java doc. So if I go to the Java doc, copy, there you go. This is the content. The way it's done, there is a pre tag that we use, and we have some auto-tested attribute that does not do anything. It's a message to our automated test to evaluate this build script logic and make sure that if there is a typo, it's going to report a problem. Running out of time, so I'm not going to demonstrate that, but I just want to mention that we have this nice capability. The test extracts all the sample or all the code snippets from the pre-Javadoc tags that have auto-tested attribute, and then evaluate Gradle builds against them. Another thing that is pretty interesting is we also do it for the Java code. All right. So the tooling API is an example of the API that you might want to use from Java code. For example, you have a Java application that you want to embed Gradle with. So if I go to Gradle connector, which is one of the classes of the tooling API, there you go. You can see that there is a Java code sample here. I'm sorry, my laptop is really slow. I know I said it again. Okay, so this is a sample. This is a Java code here, all right? And then there is a tooling. Hang on, it's auto. Actually, I'm going to demo this one because that one is interesting. So there's the auto tested samples. This is the one. Yes. So this is pretty interesting because it uses the Java 6 compiler API to compile the code that is in the found in a sample. So there you go. This is how it works. This test is not really nicely abstracted. You see there is a little bit of an incidental detail here, but the reason is that we haven't found yet another use cases for that. We only use that for a couple of classes for the tooling API. So if I go back to the Gradle connector, I'm gonna break it. For example, I'm gonna make a typo in the sample. I'm going to run this test again. It's going to fail. Yeah, you need to see at least one demo of those nice automatic, auto-tested documentation so that you really believe me. Yeah, there you go. It's failing. And it should fail for the right reason, saying that, there's a compilation error and there's a typo there. So let me quickly jump. If you have any questions, no questions. So let's move on, because I haven't even covered the build pipeline yet. We also automatically deploy the documentation, like release notes and all that stuff. So if you, for example, go to Gradle.org, the nightly build, for example, you can take a look at the release notes that has been released overnight. And then you can already see some of the stuff we have planned for Gradle 1.4. Some new ways of hooking into the dependency resolution, very nice. And improvements to the dependency resolution reports, very cool stuff. So this is an aspect of the automation of the documentation and release notes. Code quality is really important for us. We use Checkstyle and CodeNarc plugins to make sure the code is good in various aspects, like the license headers are good, the typical programmer errors are detected, the format of the code is consistent, and we found it really, really useful. I know that it's sometimes annoying that the build fails because you forgot to remove the unused import, or you forgot to remove the white space. But I have to tell you this: if the code is formatted consistently, it is just so easy to read it. It's just so easy to do code reviews without reformatting it before you even start reading it. So definitely I recommend the code quality stuff. In Gradle project, our configuration for the code quality stuff lives in a separate build script called code quality. And this is again interesting an example because we customize the setup of Checkstyle and CodeNarc. We have some custom configuration and some suppressions for Checkstyle and CodeNarc. So you can find out an example how to do it in our Gradle build. Okay, let's move on. Okay, so the build pipeline. So you can read a lot about build pipeline out there, so I'm not gonna get too deep. The idea with the build pipeline is that the change travels through the pipeline and more rigorous validation is applied to this pipeline. We have, in theory, you can say that Gradle has two build pipelines and they are identical. One is for the master branch, which contains all the development, and one is for the release branch. Release branch is something that we start using like few days, about a week before the release. So we at some basically how it works is after about 4 weeks of development, we basically decide that from now on all the new stuff goes to master, and we just finish off some things and polish the documentation in the release branch and then release from this release branch. So release branch is a long ongoing branch and all the releases comes from that. And the build pipeline we have is implemented for the Team City. Our structure of pipeline contains the static analysis, testing, and more rigorous testing, and finally to the promotion of the change. And this is really interesting. So in order to release Gradle, we don't build everything from scratch. We promote the change that has passed to the pipeline. Okay. So let me just quickly see. No questions. Okay, cool. So I guess the easiest way to explain the pipeline is to go to Team City and show you some things. So let's take a look at. So I'm going to show how it is implemented in IntelliJ, but obviously the build pipelines is something that all this continuous integration servers provide these days. So you can also achieve that with Jenkins, Bamboo, or whatever other continuous integration tool you use. So as you can see, we have projects that we call QA checkpoints, and they are kind of gates or stages, starting from the Linux basic coverage through the also Windows coverage, then full coverage, and final. And those 4 builds, they are not actually building things. They are more like grouping the other builds together. So let's take a look at the final one, because that one is interesting, and I want to show you the build chain. Okay, so don't worry that you see a lot of snapshot dependencies here. It's because the stage 4 is at most rigorous, and basically every single build has to pass. And there's constant development on our side. We heavily use CI to experiment with some hardcore bugs, or we fix some problems, and therefore you might see that the snapshot dependency is failing, but it's usually the reason is that there is some very peculiar test that is failing on a very peculiar combination of platform and Java, and we know about it. We are actively looking for a solution, but the effect is that the final build does not pass. But the closer we are to the release date, the more the more rigorous the more tests are fixed and more problems are resolved, and then all those things are green. And basically, we never release if all tests aren't green. So take a look at in the middle of January to this build. Everything will be green, I promise you. But let's take a look at the build chain, because this shows how it works. So basically, this is an example. So the first step of the build pipeline is the code quality and the static analysis. The next step of the pipeline is building. It's running the build with tests on Linux with Java 1.7, is building distributions, and running the build and all tests against Java 1.6 on Windows. And then you have a full coverage. It means a matrix of versions, platform and Java version. And then finally, there's a master, the QI checkpoint number 4 that basically groups all that together. So let's get back to the presentation really quickly. Hello, can we move? Okay. So one other interesting aspect of the build pipeline is that we reuse the binaries. They are pushed to the downstream builds, and binaries are reused. So to show you an example, let's take a look at one of the sorry, it's not going to be more than the next 5-10 minutes of this webinar. Sorry that we are running out of time again. Okay, all right. So I wanted to show you the dependencies, how they are configured in TeamCity. So we have coverage builds. So let's take a look, for example, at the cross-version tests on Linux with Java 1.5. And I'm going to go to the configuration. I'm going to go to the build dependencies. So there are snapshot dependencies and artifact dependencies. Those are the TeamCity concepts. Don't mix them up with Maven snapshots or IV artifacts and stuff like that. So more verbose documentation about that is on the TeamCity pages. Snapshot dependencies are intended to use so that a particular change travels down the pipeline, and basically, if this build they have a snapshot dependency on any build, it's going to basically run the build with exactly the same version revision as this dependent build has run. So snapshot dependencies are for building with exactly the same revision. And artifact dependencies is a completely different thing. It's a capability that enables consuming the build artifacts from a different TeamCity build. Okay, so we are, for example, this cross-version tests for Java 1.5, they consume the build artifacts from the build distributions project. Okay, so this is that. Release cycle. Okay, so I mentioned already the release cycle. The interesting thing I want to stress is the promotion of the build. So again, we implemented a way we created a small project that allows us to promote our builds, and we hooked that up to the TeamCity in a way that to, for example, release a new version of a nightly build, I can do as little as go to that build. Hello, okay. I need to go to one of the green builds. So let's say this one, and then I can do build actions, promote, and I can promote it to the, maybe different build I need to promote. It doesn't really matter. Basically, I can promote a particular change from a specific build into, for example, to be released to the nightly build. And this is really cool because what it gives us a one quick deploy, right? So the Gradle nightly is deployed overnight, but sometimes we have a need to deploy nightly in the middle of the day, so that to make some change available for a client or for someone, then it's very easy. You go to the team city, you promote a change to the nightly build, and there you go. Let's move on. Promotion, I've mentioned that already. So I guess the most important and most useful aspect of that is that this is just one click at the CI server. So I wish everyone this kind of way of releasing software, just one click and it's there. And this applies also to the Gradle.org pages. So whatever you see in the Gradle.org, it's also released with like one click. So our delivery and release does various things, including the building and smoke testing and various decoration, uploading the documentation and binaries to the correct places. There is a little bit of a manual process by the end. Because, for example, we want to use somewhat personalized announcement to the forums explaining, hey, this is a brand new version of Gradle, please take a look at that. So not everything is automated, but some of the things won't be automated because some of the things just conceptually require the human decision. But then, nevertheless, we automate everything that we can. And if I have to give this similar webinar next year in the late 2013, I bet that it will be completely different. I'll be stressing out different things, more automation that we've added, more interesting things we've automated. Okay, let's move on. And I see that we have a question. So do you change the version number inside your jar zip? If not rebuilding, how does it get changed? Very good question. So actually, when we are released, the promotion build actually rebuilds the binary. So it's building it. That's why we can have the customized imposed version number. However, we don't run all the tests because it does not make sense to run all the tests because we know that this particular change has went through the entire pipeline. So that's how it's done. Gradle, I'm hoping that this answers your question. Gradle.org page is data-driven, which means that non-techies just update some YAML files or some content files and then they push. Gradle.org is also maintained in Git repository. So when they push, it's immediately visible at Gradle.org pages. Which is pretty cool from the standpoint of automation. And another interesting thing is that we do have tests for the Gradle web presence. So if you look here, Gradle web presence, there's a Gradle.org check, and the thing that is testing, it's basically crawling all the links on the Gradle.org and making sure that none of the links lead 404 or 500 error or any kind of errors. So in theory, thanks to our automation, we are sure that on our web page we never face the situation where some links give you 404, let's say. Okay, so let's move on a little bit. So some of the automation aspects of our defect tracking and planning, we use Gradle forums as an entry point for users' feedback, questions, problems. Then we use Jira instance available at issues.gradle.org. This is for the more technical discussion of the defects that we acknowledged and we want to fix. And then we use Pivotal Tracker for the team planning. All those systems are synchronized in one way or another. For example, we can very easily push a forum ticket to Jira, it's done automatically, and it provides really nice links between those two systems. Similar in the pivotal tracker, we can import Jira tickets we want to work. So those we've synchronized those systems together to basically streamline our cooperation in our distributed team. And we have added also interesting automation. Actually, Luke Daly added interesting automation in that area and other two. It's stuff that we've added on top of the forums. So let's actually take a look. Actually, no. So the recent news that you see here, those are the forum entries. So if you click on that, you go to the forum. And basically what we've done is if any of the Gradle team creates a content in the forums and tags it with the news tag, it automatically arrives to the recent news. All right, and it's the same case for the roadmap. Okay, so we have a roadmap item here. Roadmap items are also is also a content in our forums, and if the forum entry is tagged with roadmap, it automatically arrives in our on the Gradle.org pages. Some stuff here. We've also added some automatic linking to the Gradle tickets. So, for example, you can just do Gradle 1234, and it will automatically link to the Jira instance. And we have those small, nice automations like that also for documentation. Okay, let's get back to the presentation. Wow. Okay, cool. If you have any questions, then I guess it's kind of too late to ask them because we are 7 minutes out of time. I would thank you very much for attending this webinar. A few words about us. We are Gradleware, a company behind Gradle. We offer consulting support, services, and all the stuff that you might need if you want to tackle automation challenges in your project. Again, thank you for attending the webinar. Feel free to give us feedback and hook up to us on the Twitter and the Gradle.org pages and hang out at the forums. See you later, and hopefully I can have you on the next webinar. See you guys.